Hello ladies and gentlemen, this is Mr. Janes, and now we're going to talk about distance, right? How to find the distance between 2 points on a coordinate grid. And I'm going to start the same way that I started slope, okay, except it's going to be distance. Distance, right? Okay, so if you've got 2 points on a coordinate grid, like right here and right here, you want to find the distance between those 2 points, right? Let's say you've got a graph in front of you like this. The easiest way to do that is to start the same way we start with slope, right? We draw this triangle here, our rise and our run, okay? And we figure out how what our rise is, in this case -2, and our run 6. And the reason we do this is because when we draw this kind of triangle right here, okay, this is a very special kind of triangle. This is a right triangle, okay? And so a right triangle, we've got a theorem, the Pythagorean theorem, that tells us if we know what 2 of the sides are, maybe these 2 shorter sides, it will tell us the length of this longer side. And the length of the longer side is the same as the distance between those 2 points. Right? In case you've forgotten, the Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the shorter 2 sides, and c is that longest side, that distance we're looking for. So let's check what we have in the other picture. Let's see. Our a would have been -2. Okay. Our b, so our a was -2, our b was at 6, and c was this distance that we're trying to find. Okay, so let's plug those into Pythagorean theorem, just like this. So let's see, -2 squared plus 6 squared equals c squared, and c is that distance we're trying to find. Okay, so -2 squared. This is tricky. Remember, when you square a number, you're multiplying it by itself. This is the same as -2 times -2, which is +4, right? A negative times a negative is always a positive. It's 4 plus 6 squared. 6 times 6 is 36, okay, equals c squared. 4 plus 36 is 40. Equals c squared, and we're not quite done yet because we're looking for what c is. Because remember, c will be the distance in our problem. Okay, so let's see. So to cancel out this square, I've got to do the square root to both sides. Okay, cancel each other out, and there's the square root of 40. Okay, and if you have a calculator, which I have in my bag right here, okay, we can take out our calculator. Okay, and we can look. Let me turn it on. Okay, and we can do the the square root of 40. Okay, and that appears right up here in our calculator, square root of 40. And that's about 6.32. We'll round it to 2 decimal places, so 6.32. Okay, so 6.32 is c, and that's our distance. Okay, that's our distance. So now we can go back to our picture and say, okay, from here to here is 6.32. That's the distance right there. Okay, but you're not always going to have a graph with you. So what do you do without the graph? Well, you've got 2 options, right? You can use the Pythagorean theorem again, or you can use the distance formula. Just like slope, we had a formula way of doing it, we had a non-formula way of doing it. Okay, we have both here as well. Let's take a look at those. Let's say just given the points, okay, and here are the points that I had before, okay, just like from the last problem. My points, and I want to find the distance between those 2 points. I'm going to do it 2 ways, once with the Pythagorean theorem, once with the distance formula, and show you how they both end up the same way. I'll start with the Pythagorean theorem. So, remember, how do we figure out what this number is and this number? How do we figure those out? Well, we counted our rise and our run to get -2 and 6. But what if we didn't have this picture in front of us? Well, we've actually done that before. Think back to when we talked about slope, okay, and we found the change in y and the change in x without ever looking at the graph. We just saw, okay, how far is it from 2 to 0? Okay, that's going down 2, it's -2. How far is it from -3 to 3? 6. We got the same numbers as we did up here. Okay, the same thing will apply when we look at distance. So if we have these two coordinates, we look for our change in y, okay, -2 to 0, which is -2, and -3 to 3, which is +6, Okay, we found our change in y, our change in x, and we're going to put those right in the formula just like we did before. So negative 2 squared plus 6 squared equals c squared. Okay, negative 2 squared is 4. 6 squared is 36 equals c squared. 4 plus 36 is 40 equals c squared. And I've got to get rid of that square, so I take the square root. The square and the square root cancel each other out. And so, just like before, this is 6.32 equals c. There's our distance, right? Distance. Okay, that's one way to do it. Okay, by finding the change in y and the change in x and putting it into the Pythagorean theorem. Now you could also use the distance formula, but you're actually doing the same exact thing. Think back to when we talked about slope. Okay, we did it once by finding the change in y and the change in x and simply putting them as a fraction and simplifying. We also did it by putting them in the formula, okay, y2 minus y1, x2 minus x1, and simplifying. And we got the same answer either way. The same thing will happen with distance. Okay, we could find the change in y and change in x and put them into the Pythagorean theorem, or we could just put these numbers as is into the distance formula. Okay, again we have y2 minus y1. So just based on how we did slope, we did y2 minus y1, that was the same thing as the change in y. So when we do y2 minus y1 here, we better get negative 2. And when we do x2 minus x1 here, that's the same thing as the change in x. So we better get 6. Let's see. Giant square root of, let's see, y2 is 0, minus y1 is 2, plus x2 is 3, minus negative 3 squared. Okay. 0 minus 2 is negative 2 squared, plus 3 minus negative 3 is the same thing as 3 plus 3, which is 6 squared. Oh, almost forgot this big square root. Okay. Negative 2 squared, that's 4, right? Because whenever we square a negative number, it's going to become positive. 4 plus 6 squared is 36. Oh, almost forgot the square root. 4 plus 36 is 40. Square root of 40. And if we pop that into our calculator, like we did before, we will get 6.32, and that is our distance. Okay. Now, I got the same answer. And I should, right? These are two ways of doing distance, and they're literally doing the same exact thing, right? We're finding the difference between these numbers, okay? We are squaring them, okay? We're squaring them, so we get the same numbers here and here, okay? We are adding them, okay? The same numbers here and here, and we get the same answer. So this is literally the same exact thing. I prefer to use the Pythagorean theorem, and this whenever my numbers are small, or if I've got a picture of the graph in front of me, like I did up here. Okay? If your numbers are big, or you don't have the picture of the graph in front of you, the distance formula is probably the way to go. But they are literally doing the same exact thing. In fact, if you ever forget the distance formula, you can figure it out by using the Pythagorean theorem. Okay? So, in the next video, we'll do a practice with a couple of these, and then you'll be on your own.